Hello people, today I would like to talk to you about liquid cooling. This is part 1. We will talk about CPU blocks, their tests and results, jet plates as impingement jet cooling effect. Those will be with different blocks, flow rates, pressures on different sockets, and flow rate and pressure, how do they affect cooling efficiency. Why listen to me? Well, last year I was second in Enthusiast League, and this was the end of the year. As you can see, I was second and fourth in Enthusiast League overall, 62nd in the Global Masters. Well, the situation changed and I'm 53rd on Global Masters charts, so you can see that I'm pretty high, even over their Bauer era tracks. But anyway, what I would like to talk to you about was the CPU blocks, and chosen for this test was EKWB Velocity, Aquacomputer Vision, Kryos NEXT with Vision, Phanteks Glacier C350i, and Supreme HF from EK This is 10 years old water block. And hardware for tests was Open Bench Table, ASRock OC formula with two CPUs i9-7940X with high frequencies, i9-7980XE with also high frequencies. Those were with DDR4 32 gigabytes. Those were 4 sticks of 8 gigabytes of RAM. The tests for X5690 were performed on P60WS from Asus and with Predator memory at 1866. Those were DDR3. Seasonic 1300 watt gold, Samsung's 960 Evo 500 gigabytes on M2 slot, and I was using universal liquid cooling system for testing, which was designed by me but created with extreme hardware, and this is ULCFT Mothership. This is big. So we have here two 560 radiators and 280 radiator. This is all hanging on the wall, and we can see that there's a push-pull configuration. There's Corsair 450 watts PSU, so we are totally omitting the power drawn by fans and by pumps from the PSU connected directly to the motherboard. So any change in flows and all the stuff, this doesn't even get any effect on PSU or motherboard voltages or anything. So the flow rates are high on this thing, so about 14 liters per minute without blocks, 11, almost 12 liters with CPU and GPU blocks, and 10.4 liters with two CPU blocks. The most tests were performed with 2 blocks on 2 different lines, so the flow was, when I'm talking about 10-liter flow, we have in fact the flow about 5.5 liters per single block. Cooling power is enormous, because this is about 10 kilowatts of power when it's going on high RPMs, and 7 kilowatts of power, cooling power, when we are at 650 RPMs. This is due to the push-pull configuration. It was made, as I said, with extreme hardware. Those guys are great in very big configurations, the extreme rigs, and so we were designing it. Well, I designed it, but I wanted to create that with them. I will leave a link to their channel. It's in Polish language, but most of graphics and comparisons are very readable for anyone. So, testing conditions. Every time I've changed the water block, I was applying a new thermal paste. Every time loop was cooled for 2 minutes between any tests, in the meaning of testing single block. Ambient was about 30 degrees of Celsius, so hot. Fans were all the time going 650 RPMs at minimum. There was a single exception to this when I was wanting to show Kryos NEXT with vision and how does it scores against Velocity, EK water blocks, and so that was the one. You can change that video, you can check this video on my channel. Those tests were performed in 2 days, and this was controlled environment. I have also infrared temperature measuring equipment, so up. Now, LCCP water block specifics. Phanteks Glacier C350i. No jet plate at all. Nothing is steering the flow of the liquid. Kryos NEXT with vision. White injection. No jet plate. EK water blocks velocity. Well, there is a jet plate for 1150 and 2011, 2066. There is only a difference in thickness. There is a jet plate with 0.7 millimeters and 1 millimeter thickness. The same nozzle every time. And Supreme HF has 4 usable jet plates, different amounts of channels on them. Phanteks Glacier, as I said, there is no jet plate at all. Kryos NEXT with vision. This is the nozzle. It's quite big. EK water block velocity. A little bit more restrictive jet plate, but still big. Now, outcomes. i9-7940X 4.9 GHz, only velocity could sustain test under 100 degrees of Celsius. AC Kryos couldn't hold it at 4.8 even. Glacier was turning off testing rig in few seconds. i9-79XE Glacier was tested only at 4.6, almost all tests at 100 degrees of Celsius. Kryos also landed above 100 degrees of Celsius, right at 4.7. Velocity was able to hold CPU under 96 degrees of Celsius at 4.8 GHz and at 4.9 GHz under 101 degrees Celsius. There is a film on my channel. Now, the summary. Velocity was clearly a winner, but Supreme HF somehow got into the game. Well, somehow. I bought it to test LGA 775 and LGA 478 or 476. At the start I used the jet plate number 4, and I'm referring to it high flow, and I was really sure that this will be the best choice for my cooling power and the pumps that I use, dual revo D5 pumps. But now let's get to the jet plates. What is it? It's a restriction plate which is used to control the flow of the liquid. This is mainly a piece of metal with a nozzle in it, so there's a hole in it in different shapes or different lengths. And in standard, how does the manufacturing sees it? It does control the flow through the fins of the water block cold plate. This name jet plate refers to impingement jet cooling. Water block manufacturers that states that it only directs the flow of the coolant, but does it? Well, the jet plates and impingement jet are working like this. There's a nozzle. This is the flow of the liquid. We have the potential core, the mixing region, and the stagnation point. Okay, and this is another graphic here. This is the potential core, stagnation region. The higher the flow, the lower stagnation region. If now the theory of impingement jet, it is complicated. There's a fluid pressure and velocity, viscosity of the medium, the Reynolds number, Nusselt number, those are thermodynamic similarity numbers, distance of the valve, so the nozzle outlet from the cooled surface, and shape and size of the nozzle and cooled surface shape. That's the thing what I am thinking about. So cooled surface shape, that is the thing that is holding back manufacturers from thinking about this kind of cooling as impingement jet cooling. Do we have impingement jet in liquid cooling for PC parts? Well, the turbulence of the stream is extremely important phenomenon. It minimizes the stagnation zone, and the cooling medium receives more heat energy from the impacted surface. Well, I wanted to check if there's a correlation between liquid cooling pressure, flow, velocity of this flow, and the temperature in liquid cooling. So this is the thing. Here has to be turbulence. I'm sorry, this is in Polish. Well, EK water block tips. So I asked EK water blocks what do they think about the impingement jet, and they said I would not recommend treating them as impingement jet. So those are only restriction plates, and that's all. Use the jet plate which is in the instruction. The outcomes. And it's got interesting because I decided to test i9-79 80XE, 80 cores, and X5690 with 6 cores at similar clock speeds, with 3 different jet plates in different configurations of pressure of liquid flow through the block. So 10 liters and 5 liters. If we want to have higher flow, the pressure will also increase. EK Water Block Supreme comes with 5 jet plates. 4 of them are usable right out of the box. The number 1 was used as a low flow. The second was as right flow because it was recommended. And the 4th was used as high flow. Result for X5690. As you can see, there are no extreme differences here. Those are maximum temps. So we can see that also the highest flow can give better results sometimes. Right flow is getting better, but high flow at the high flow restriction plates with lower flow velocity gives a bad result. So here we have, there's a difference from high flow, right flow, low flow jet plates, but there's also all the time 5 liters of flow, okay, all the time. So we see the more restrictive jet plate, the better the temperatures. Here we have with the big amount of liquid going through the block, this is not that easy to see. those are the max temps in a different view. Okay, so we can see that the high flow is sometimes better for some benchmarks, even better than the right flow, but we cannot say it's also always optimal, because for GPUP, for example, we can see that this is worse than right flow. Those are the minimum temperatures. You can still see that the right flow and low flow are directly against each other. But if you are having lower flow of the liquid, you have worse temps. Here you have it like this. But this is only 6-core CPU. Oh, alright, 4.8 gigahertz. But now let's get the results for i979XE. So those are the temps with jet plates, min max for high flow. So this very unrestricted jet plate. Here we have the right flow and the low flow. And we can already see here that the more restrictive jet plates, the more restrictive nozzle of the jet plate, then we have the better temperatures. Even with the lower velocity of the coolant, and lower pressure, we still can see that this changed. The more restrictive jet plate is, the better temperatures. Those are the max temps. Differently shown. You can see that low flow, so very restrictive jet plate with the flow of the coolant about 10.2 liters to 2 blocks, so 5 liters per single block. So this is almost D5 without any big restrictions, so very good radiators. Okay, and we here have the best cooling power. Minimum temperatures, not so big difference as you can see, but also the right flow and the low flow jet plates are sometimes very near each other, but most of the time we have the best with very restrictive jet plate. And now we came to EK water block velocity. This is still 4.8 gigahertz because I came back to see those results. And this is for 2 CPU blocks connected in this loop, and this is for a single block, so only velocity connected. The other one was cut off, and now we can see that dual Revo D5 pumps are pumping 7.6 liters through that block. These are the temperatures, maximum temperatures. These are the minimum temperatures. So, how then EK water block velocity scores against Supreme HF in tests? That's the scores. Those are for 2 blocks all the time, 2 blocks, okay? So for a single blocks it's about 5, and here about 2 to 3 liters per minute, and these are velocity for 2 blocks and a single block on the line. And we can clearly see that 10 years old construction in meaning of max temps will be almost 20 degrees of Celsius, over 20 degrees of Celsius better than the new, with the wide nozzle, and we can see that there are no big differences between having two water blocks connected to the loop or just a single block when the pressure is high. But still, Supreme HF with low flow, so restrictive jet plate, is the best. Supreme LF, even so Supreme HF, but with restrictive jet plate, even at 5 liters only, so big pressure, because two blocks connected, it's still better than Velocity. That's kinda weird, huh? And I'm reminding you, the Velocity was the best block of all blocks tested. So these are minimum temps, and we still have the same result. Supreme HF with low flow restrictive jet plate. We have it here, the red one. So conclusions regarding the occurrence of impingement jet in EK water blocks. Well, we have omitted totally the cooling power of radiators, and we have a clear correlation between liquid flow rate, pressure, nozzle size, and the temperature when this cooling power is omitted. The higher the pressure and the flow rate, the lower the temperatures. The smaller the nozzle, the lower the temperature. The issue of X5690 cooling with different jet plates, it's not so obvious. In HVX it's different, and those are mixed results, but the trend is still visible. Result for lower pressure, the lower the pressure, the worse the temperature. So clear correlation here for the nozzle size. Looking at the results with the flow through a single block. So Velocity 7.6 liter single block Revo D5 dual pumps. You can see that increasing the pressure of the liquid sometimes it is not giving the better results. So heating values that are maximum for D5 pumps minimally sometimes reduces the ability of cooling and increases the temperature. The difference was about 5 liters per minute and 7.6 liters per minute, and differences in pressure was 0.4 bar and 0.7 bar. The tests were made in 30 minutes gap, and there was no change in any factor. And now let's get to the testing. Threadripper 3 Zen 2 3970X. Test parameters: motherboard Zen 82 Extreme, CPU as I said. Another time used the Mothership and EK-Supremacy STR. Ambient temperature 24 because those were performed later. Pump speeds were 7.44 liters. This is on the single block only. 4 liters single block only and 2 liters single block only. Tests were performed all differently for 1200 seconds Cinebench R20 test at 4.25 gigahertz. The rest was performed at 4.3 gigahertz. This is EK-Supremacy STR4. Results. As you can see, the maximum flow, medium flow, and low flow. You can see that there are differences only due to the flow through the water block. It might be said it's not so high, but in the long-term testing, 83, 89 degrees, there is a difference, and it's only 20 minutes, remember. Here you have it. This is only for the differences in velocity of the flow and the pressure. minimum temperatures. So, conclusions and summary of this thing. Impingement jet cooling, for me, it's taking place, the effect, possibly between fins, but it is taking place. The pressure and the flow velocity of the fluid in the block affects efficiency of its operation. The shape and size of the jet plate nozzle has an effect on cooling efficiency. The larger and warmer the CPU, the greater the effect of pressure and flow rate, especially for Intel. For STR4 with Threadripper 3, the differences are not so great, although of course significant, because up to 10 degrees Celsius in overclocking. I remind you, the tests were performed with total emission of radiators, cooling power due to usage of ULCFT Mothership with approximated cooling of the power of 7 kilowatts. Further study plans. I will check the results while using 3 different types of coolers, 360mm and 280mm sets, because those 2 radiators will be inserted in a single case. 25 to 27mm classic, 25 to 27mm fins X, and 45 to 50mm fins X, so denser fins. And I will check Threadripper 33970X operation with SPC pump and D5 pumps in long-term tests, so for rendering or simulated rendering. I will check also performance on STR4 with heat killer water block. Well, before I get to the end, I would like to show you. This is how it looked in testing. So for every kind of the test, I was creating screenshots and then checking, getting it to the Excel. Okay, so every parameters was inserted. And yep, so that's the way the cookie crumbles. Thank you for your time. I hope I've cleared some things for you, and have a good day. Thank you. Bye.